4.3, which is analyzing the quadratic function. So thinking back to what a quadratic function is, the standard form of the quadratic function is f of x equal to ax squared plus bx plus c, where a, b, and c are constants. Examples of a quadratic function might be, say, f of x is equal to negative 3x squared minus 2x plus 5, or f of x is equal to 0.5 x squared plus 5x minus 17. Those are all examples of a quadratic function in the standard form. Now, there's a second form called a vertex form, which is written as f of x is equal to a into x minus h squared plus k. And this could be some type of equation, or we'll get more into this later on, such as 3 into x minus 2 squared plus 5, which could be if you squared x minus 2, multiplied it by 3, and added 5, you would get the standard form of the function. So I wanted you to be aware of these two forms before we continue. Now, let's talk about a little bit about what the meanings of the words, the A's and B's are. The vertex is the minimum or maximum point. And it's given the designation H and K. And the reason we would state minimum or maximum is depending on which way the graph is turned. Let's draw a couple of graphs here. So if I have a graph, say, that's turned this way, then I would have a minimum point. Remember, a minimum point is a low point, okay? And that minimum point would be the vertex. Given the coordinates h and k. And if the graph was perhaps turned this way, turned downwards, it would have a maximum point that would still be called the vertex, h and k. So, auto rules, if the value of a is greater than 0, the graph is turned upwards and has a minimum point. Such as if we have f of x is equal to 3x squared minus 2x plus 5, the a value here is equal to 3, which is a positive number. It's greater than 0, so this graph is turned upwards and has a minimum point. If the value of a is less than 0, the graph is turned downwards. Remember, a number that's less than 0 is a negative number. Okay, negative. And if something is greater than 0, it's positive, yes? Okay, so if the value is less than 0, it has a maximum point. In other words, the graph is turned downwards. Okay, graph is turned downwards, such as if we have f of x is equal to negative 5x squared plus 7x minus 2. We have a is equal to negative 5, which is a number that's less than 0, which is your clue that the graph is turned downwards and has a maximum point. In addition to that, if we think about the graphs here, we can define something called an axis of symmetry. A vertical line going through the center of the graph, okay, is called the axis of symmetry. And the reason it's called the axis of symmetry is that if we folded the graph on that line, we would have exact values to the left, and we would go exactly the same number of units to the left and to the right. So this is not properly drawn here. Maybe I can do a better job drawing it. This. If we went a units to the left, we would also go a units to the right. Now that axis of symmetry is a vertical line, and remember that the equation of a vertical line is x is equal to some number. In this case, this is the h value of the vertex, so x is equal to h is the equation of that vertical line. All right, example. Given f of x, we're not at example yet. Given f of x is equal to ax squared plus bx plus c. Okay, that's the standard form. To find the vertex, use h is equal to the minus b over 2a. This is a formula. And the k value of the vertex is the function substituted with the h value. So now we can do an actual example, yeah? Find the vertex and axis of symmetry. Also state if turned up or down or a maximum. So the first equation we're going to look at is f of x equals to x squared minus 2x minus 3. So first we're going to compute the vertex. The h value of the vertex is equal to minus b over 2a. So a is equal to 1, b is equal to negative 2. But direct substitution here, we have negative of negative 2 over 2 times 1 is equal to 1. So the h value of the vertex is equal to 1. And the k value of the vertex is f substituted with 1, which is 1 squared minus 2 times 1 minus 3, which is negative 4. So the vertex hk is 1 and negative 4. This is a minimum point. How do we know that? Because a is equal to 1, which is a number that's greater than 0, so the graph is turned upwards. Okay, the graph is turned upwards. So we want to go ahead and graph this function and check our answer with the calculator. I'm going to show you a couple of things on how to find this vertex with your calculator. So open your calculator. Y equals, clear whatever you have in there and type in your function, x squared minus 2x minus 3. Notice I'm using minus signs, not the negative button. Now and graph it. Now I kind of messed up my window before because I was doing something in statistics. And also remember, if you have the dot plot on, to go to second stat plot and take off the dot plot. Okay, so we're back with the graph, and in order to see this has a weird window. In order to see the right window, we would press zoom and number 6, zoom standard. So zoom standard is the default setting, 10 points in each direction for the x and y axis. And there we see the graph with a minimum point at 1 and negative 4. If you wanted to ask the calculator to compute that minimum point, you press second, calculate number 3, minimum. And what you want to do is go slightly to the left of that minimum point and press enter. Then go slightly to the right of that minimum point and press enter. And then the calculator makes you an offer. Says, do you want me to try to guess that minimum point? And it will guess the minimum point for you. Now, sometimes you get the exact value, sometimes you don't. Other times, depending on how close you put your parameters to the left and to the right. So let's do it one more time. Second, calculate minimum. I'll go slightly to the left and then slightly to the right and press enter. And now it's given me 1 and negative 4 again. So be careful. Just take it to the nearest decimal point if you want, and you get your answer 1 and negative 4 as the minimum point. So notice this is showing us everything. It's showing us that our graph is turned upwards and it has a minimum point. We've demonstrated all of this. All right, let's take a second example. Example 2. say f of x is equal to negative 2x plus, negative 2x squared plus 2x plus 3. So we're going to go through the same process, find h, which is minus b over 2a. We know that a is negative 2. We know that b is positive 2. Making our substitution here, we have negative 2 over 2 times negative 2, which is 1 over 2, or 0.5. For the k value of the vertex, we would substitute half into the original function. We have negative 2 half squared plus 2 times half plus 3. So this is equal to 2 half times half. So this is negative half. And then 2 and 2 cancel out to give 1 here plus 3, which is equal to 3.5 or 3.5. Now the a value is equal to negative 2, which is less than 0. So the graph is turned downwards. Down. The vertex h and k is a maximum point at 0.5 and 3.5. Oh, by the way, I forgot to put in the axis of symmetry. X is equal to the h value of the vertex, 0.5. I also forgot to put in the axis of symmetry up here. Axis of symmetry is x is equal to h, or x is equal to 1 in this case, because the h value is 1. Okay? X is equal to h, which is, in the h is 0.5 in this case. So again, we're going to do the same thing. We're going to go to our calculator and graph this function and see if we're correct. So y equals to negative, notice now I'm using the negative button, not the minus button, 2x squared plus 2x plus 3, and graph it. So we want to calculate the maximum point, that maximum point right there. And again, if you're not sure what it is, you can ask the calculator. Second, calculate maximum, number 4. Go slightly to the left of that vertex. Press enter. Then go slightly to the right of the vertex and press enter. And then have the calculator guess the answer for you. And it will take you as close as it can, 0.4999, which is approximately 0.5 and 3.5. So we've calculated the vertex to be correct at 0.5, yes? And 3.5. Notice that we've verified that the graph is turned downwards and that the vertex is at 0.5 and 3.5. All right, so let's do one more example. I've got, say, f of x is equal to x squared minus 2x minus 15. So h is equal to minus b over 2a, which is minus negative 2 over 2 times 1, which is positive 1. K in this case is equal to the function substituted with 1, which is 1 squared minus 2 times 1 minus 15, which is equal to negative 16. The a value is equal to 1, which is greater than 0, so the graph is turned upwards. Turned up. The vertex 1 and negative 16 is a minimum point, and the axis of symmetry x is equal to 1. The h value of the vertex. So let's go ahead and graph this one. X squared minus 2x minus 15 graph. So remember, we computed that that vertex is at 1 and negative 16. We can't see the vertex. So we need more negative y values to see this vertex. So to fix that, go to the window. And the only thing you're going to change is the y minimum. It's at negative 10 right now. Let's make it about negative 20 because we want to see negative 16 and graph it. And now we can see that vertex. We can compute that vertex at 1, and we'll see that when x is equal to 1, y is equal to negative 16. Notice that everything else is confirmed. This is a minimum point, and the graph is turned upwards as we expected. All right, the next thing I want to talk about is the intercepts. And we've already discussed intercepts in previous chapters, so this is just a quick refresher. Intercepts, all quadratic functions have one y-intercept. And let's see what's happening here. So let's get a variety of graphs. Let's say we've got a graph that looks like this. No matter where it is, it's going to have a y-intercept. Okay? Or it's like this. It's going to have a y-intercept. Or it's like this. Let me draw a couple more here. Okay? Always have a y-intercept. So to find, all we would do is set x is equal to 0, and we would get the y-intercept is the constant. When x is equal to 0, it's the constant term in the f of x is equal to ax squared plus bx plus c. Because if we set x equal to 0 here, we would be left with c. So the y-intercept is always the constant term. Now, Quadratic functions may have one, two, or no x-intercepts. For example, in this one here, we have two x-intercepts. But in the graph above it, because it's turned upward, it does not cross the x-axis. So it only has a y-intercept, no x-intercept. You could also have a scenario where, let's take two more examples really quickly. If the graph is turned downwards like this, it would have no x-intercept, and it would have a y-intercept. Now, it could also have one single x-intercept if it goes up and touches the graph, one x-intercept. Okay, so be prepared that it could have one, two, or no x-intercepts depending on what the situation is for the graph. Now I'm going to give you a few steps to analyzing the graph of a function. To analyze a quadratic function. Step one, you determine if it's turned up or down. Remember, to be turned up, a has to be greater than 0. And to be turned down, a has to be less than 0. The second step is to find the vertex, h and k, and decide if it's minimum or maximum. Okay? And we know that if it's turned upwards, it will be a minimum. If it's turned downwards, it will be a maximum. 3, find the axis of symmetry, which is x is equal to the h value of the vertex. 4, the x-intercept, set y equal to 0, and the y-intercept, set x equal to 0. 5, find the domain. Now, the domain of the quadratic function, as we know from previous chapters, is negative to positive infinity, all real numbers. And the range could be from k to positive infinity, or it could be from negative infinity up to k. Okay? So if the graph is turned upwards, for a graph that's turned upwards, the range would be from whatever that k value is up to infinity. And if the graph is turned downwards, then it would be from negative infinity up to k, which is what this is saying. So if a is less than 0 and the graph is turned downwards, then the range would be negative infinity and the k value. And step 6, you would have to determine if the graph is where it's increasing and where it's decreasing. So let's see how this works. If we wanted to analyze, say, f of x equals to x squared minus 2x minus 8. Step 1, a is equal to 1. The graph is turned up. Yeah. And while we're doing this, we're going to go ahead and do a very simple sketch of this graph. You're going to have tools in my lab to help you with this. Okay. Okay. Step 2 says we find the vertex. H is equal to minus b over 2a, which is minus negative 2 over 2 times 1, which is equal to 1. And k is equal to f substituted with 1, which is 1 squared minus 2 times 1 minus 8, which is equal to negative 9. So vertex 1 and negative 9, and we know this is a minimum point because the graph is turned upwards. Yeah. So this is the low point. We can go ahead and perhaps mark this point here. This is at 1. And let's say negative 9 is somewhere about here. Yeah. Negative 9. So we have our vertex here. 1 and negative 9. Next, step 3 is the axis of symmetry, which is x is equal to 1. Okay, x is equal to 8, so x is equal to 1. And that is a vertical line going through the vertex. So we can perhaps draw that in. What do you think? Okay, and that's our axis of symmetry. X is equal to 1. All right, so here we go. Now, part 4, x-intercept. Set the function equal to 0. Factor it to get the x-intercept values, which if we factor here, we get x minus 4, x plus 2. So x is equal to positive 4 and negative 2, right? So we have x-intercepts at 4 and 0 and negative 2 and 0. So we can mark those points. We have, say, 1, 2, 3, 4, and then 1, 2, 3, negative 2. Notice that I've counted 3 units this way, and I've counted 3 units this way from the um, from the axis of symmetry. Okay. Now the y-intercept is simply the constant value. So y-intercept is at x at y is equal to negative 8, 0 and negative 8. So we can mark 0 and negative 8 right here, negative 8, as the y-intercept. Okay, the y-intercept is simply that value right there. What else do we need here? So we can actually go ahead and sketch our graph before we continue here. Okay, the graph will go this way. And then the graph will pass through the y-intercept and go this way. the remaining parts of this, the domain negative to positive infinity, the range, the lowest y value is -9, and it opens up to infinity. So -9 in a bracket to infinity, because -9 is an actual point on the graph. And then increasing, decreasing. So the graph falls, it falls that way, it decreases from -infinity up to 1, decreases -infinity up to 1. And remember that 1, that h value of the vertex, is the point where it would transition and it would start to increase. Okay? Increasing from 1 to positive infinity. That didn't come out right. Okay, now you perhaps want to check this with your calculator, so let's go ahead and put that in our calculator and check it. Y equals to, and I'm going to put in my function here, is x squared minus 2x minus 8. And it should confirm everything that I have. Yep, let's put this back in a standard window, zoom standard. Okay, I could see my intercepts at -2 and +4. I could see my my y-intercept at -8, and I could see my vertex. You can actually make your calculation here. You can say when second, calculate the values when x is equal to -2, the y value should be 0, and show you that. Or when x is equal to 4, the y value should be 0 again. Or when x is equal to 0, the y value should be -8. And the vertex, when x is equal to 1, y is equal to -9. So lots of ways that you can check your answer and make sure that you have the correct graph for this. Yes? I'm going to go ahead and tack that graph in here so you can look at it. Okay, notice on the graph here, this is at -2, this is at 4, and this is at -8, and that point is 1 and -9. All right, next I want to do, I'm going to do actually 2 more examples here. F of x equals to -x squared minus 6x, and I'm going to go a little bit faster here because I'm going to graph this as we're working here. So let's see. I want one. One, it's either turned up or down. So in this case, a is equal to -1, which is less than 0, so the graph is turned downwards. Yeah, we know the graph is turned down. Part 2, h is equal to minus b over 2a, which is minus -6. b is -6 over 2 times -1. Pay attention to your signs here. This is -3. And the k value is f substituted with -3, which is -3 squared minus 6 times -3, which is -9 plus 18, or +9. So the vertex HK is at -3 and 9, and that's a maximum point because the graph is turned downwards. Okay, we can go ahead and mark that at, say, 1, 2, 3, and 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, somewhere right there. Doesn't have to be exactly 100%, right? -3. Actually, no, that is very incorrect. That's +3, yeah? I'm supposed to be at -3. So 1, 2, 3. -3 and 9, this side, yeah? And this is 9. This is -3. So we can go ahead and write our axis of symmetry. X is equal to -3. And we can also draw it in, yeah? -3, that's our axis of symmetry. Okay, at -3. X is equal to -3. X-intercept, set the function equal to 0. So this, if we factor out, say, -x here, this would give x plus 6 equal to 0. So x is equal to 0, and x is equal to -6. So we've got two x-intercepts, 0 and 0, and -6 and 0. Which should make sense to you, right? It should make sense to you. This is 0 and 0. And then 3 points to the left would be -6. Okay, we'll go 3 points that way, and we go 3 points this way. So the y-intercept is the constant value here. When x is equal to 0, the y-intercept of this function is 0, because this is +0 here, okay? In other words, y occurs when x is equal to 0. So y-intercept is at 0, 0. And we can already see that. So we can actually sketch this graph right away. Go through the x-intercept. And this 0, 0 is both the x and the y-intercept. Okay? Part 5 is the domain, -infinity to +infinity, and the range comes in from -infinity and stops at 9. Okay, full stop at 9. The range is going that way. The range is coming in that way from -infinity and stopping at 9. The graph is increasing. Remember, we decide increasing as we move from left to right. So increasing up to -3, and then it's decreasing from -3 to infinity. So increasing from -infinity up to -3, and then decreasing from -3 to infinity. So increasing from -infinity to -3, always parentheses, and then decreasing from -3 to +infinity. Remember, we're taking intervals on the x-axis. Again, you probably want to confirm this graph with your calculator, and you can do that by just simply graphing it with your calculator. We have y is equal to clear this here, negative x squared minus 6x, and graph it. And you can see your intercepts are at negative 6 and 0. You can see the graph is turned downwards. And we're going to just make sure that our intercept is correct, our vertex is correct by typing in negative 3 and seeing that y is equal to negative 9. And putting that in our notes so we know that we've confirmed our graph for this function. All right, I think we did enough examples, so that's great. Let me just take a look here and see exactly how many of these problems you would have to do from the drop-down menu here. Yeah, that's excellent. All right, so now we want to speak a little bit about the vertex form. Okay. So the vertex form f of x is equal to a into x minus h squared plus k, where h and k, of course, is the vertex. Notice this does not have a b and c value. We would have to compute that. So say if we have, let me just pick on this problem here. If we have a given point 0 and negative 6, vertex at 2 and negative 10, write the standard form of the function. So this is some kind of a graph. We don't know if it's turned up or down at this point, but they're giving us that it crosses the x-axis at 0, the y-axis at 0 and negative 6, and then it has a vertex at 2 and negative 10. Okay, so that's a fair indication that the graph is, turned upwards, because it's crossing here. It has to come down to this point and then go up that way. Okay, fair indication that this graph is turned upwards. Now, to write the equation for this, we first designate this point, the given point, as x and y, and the vertex is h and k. And we go straight to that form, f of x, a, x minus the h value, which is 2 squared, and the k value is negative 10. Okay, now you want to go ahead at this point because this is y and this is x, and substitute for x and y. So the y value is negative 6, the x value is 0, minus 2 squared minus 10. And now we can see that the only unknown here is a. So this is negative 6. 0 minus 2 is negative 2 squared, which is 4. So this is 4a minus 10. And solving this, we can see that the a value comes out to be, this is 6 minus 4. So 4a is equal to 4. So a is equal to 1. So that equation is f of x, a x minus h squared plus k. We can now go ahead and fill in what we have. We know that a is equal to 1, h is 2, and the k value is negative 10. X minus 2 squared is doing FOIL, okay? X minus 2 times x minus 2 is x squared minus 4x plus 4 minus 10. So this gives x squared minus 4x plus 4 minus 10, which is f of x is equal to x squared minus 4x minus 6 is your function. One final example here, given a point, say, given h and k is equal to 1 and negative 4, and the point x and y is equal to 2 and negative 2. So let's see if we can visualize this first. We've got a vertex at 1 and negative 4. Vertex is here, and a point at positive 2 and negative 2. Somewhere about here. Okay, so this is a pretty good indication that the graph is turned upwards, yep? All right, so let's do this real quickly. F of x is equal to a into x minus h squared plus k. I'm going to make my substitution. So f of x here is negative 2 is equal to a. X is 2 minus 1 squared, and the k value is negative 4. So this is negative 2. This is 1 squared, which is 1. So 1a minus 4. So a is equal to 2. So f of x is equal to 2x minus 1 squared minus 4. Okay. 2x minus 1 times x minus 1 is x squared minus 2x plus 1 minus 4. Then you distribute. Never distribute before you do the parentheses, okay? This is 2x squared minus 4x plus 2 minus 4. So f of x is equal to 2x squared minus 4x minus 2. Um, I can perhaps do one final example with you. Say, because this is sometimes an issue to try. Okay. Let's see. Hold on 1 second. Let me pull up another problem from the homework. I'm looking for a good problem here from the homework. All right, here we go. Here's a great one. Given point xy is equal to say 2 and negative 5. Let's see if that works. 2 and negative 5. Negative 2 and negative 5, and the vertex h and k is at actually this is negative 2 and negative 5, and the vertex is at 0 and negative 9. So what kind of graph do we have here? We can probably find this graph here. If we mark a few points, it will give us a pretty good idea. The vertex is at negative 2 and negative 5, right? And the graph passes through 0 and negative 9. So this is a pretty good idea that the graph is turned downwards, yeah? So let's go ahead and see if we can figure out this graph. F of x is equal to a to x minus h squared plus k. So this a into f of x is negative 5, x is negative 2. I'm sorry, that's x is 0. I have this all wrong. F of x, the y value is negative 9. Then x is 0, and the vertex value is negative h. So negative of negative 2 is positive 2 squared minus 5. So negative 9 is equal to 4a minus 5. Okay, so a 4a is equal to negative 4, so a is equal to negative 1. So f of x is equal to negative 1 x minus negative 2, so x minus negative 2 squared minus 5. So this is f of x is equal to minus 1 x plus 2 squared minus 5. Make sure that you do FOIL on x plus 2 times x plus 2 to give you x squared plus 4x plus 4 minus 5, and then distribute your negative 1. So negative x squared minus 4x minus 4 minus 5. To give your equation, f of x is equal to minus x squared minus 4x minus 9. Just a couple other little questions here. If given f of x equals to 5x squared minus 10x, does function have min or max. So the A value is equal to 5, which is a positive number, so the graph is turned upwards. So this graph has a minimum point. To find that minimum point, remember we define minimum point as the K value. We'd have to find H first, which is negative B over 2A, which is negative of negative 10 over 2 times 5, which is 1. Okay, and then we substitute 1 to find the K value, which is 5 times 1 squared minus 10, which is equal to negative sign. So minimum point at negative 5.